Just let me maximize it and we can get started. So we were supposed to start our organic chemistry with the topic of alkanes. And yesterday I was discussing the definition of hydrocarbons. It's very easy. Hydrocarbons are compounds that are made up of only two elements, carbon and hydrogen. And we went with many examples yesterday, and I asked you a couple of questions. And by giving you these diagrams that you can see, there are many compounds. Some of them are only made up of carbon and hydrogen, and there are some other which include oxygen as well. So hydrocarbons would be the ones that are only made up of carbon and hydrogen, and whichever one that includes oxygen in terms of a red ball shown over here will not be a hydrocarbon. Simply speaking, all the compounds in A, the first compound on the left of B, the compounds given in C, are all hydrocarbons. However, this compound on the right on B and the one in D and E are not hydrocarbons because they consist of oxygen as a third element. So if they're only made up of two elements, carbon and hydrogen, it's a hydrocarbon. No matter what kind of bond it has a single covalent bond or it has a double covalent bond, it doesn't matter, but it's a hydrocarbon. Then moving on, we were supposed to study the types of hydrocarbons. So what we did is that we divided into two basic families. One was saturated, the other one was unsaturated. Saturated was the one which only contained single covalent bonds, and unsaturated was the one which contained a double or a triple covalent bond. Moving to the diagrams once again, you would see that all the structures in A are actually saturated hydrocarbons because they only consist of single bonds in here. Same goes for B, but the same is not true for C because in C, you would see that there are single bond as well as double bond. So if there is at least one double bond in the entire structure or one triple bond for that matter, it will not be a saturated hydrocarbon. It will then be bifurcated as unsaturated hydrocarbon. So these would be the main two classes of hydrocarbons. However, the families in hydrocarbons are also separated in some other way. For example, was only the bifurcation made upon the basis of type of bond, saturated and unsaturated. Now we are going to talk about specific families. In order to talk about specific families, it's not just the type of bond. There are many things that we are going to characterize that we are going to talk about their specific properties. So the families in hydrocarbons will be separated by many names, and we are supposed to study in this chapter of organic chemistry around 5 to 6 different families. For example, I quoted a few names yesterday like alkanes, alkenes, alkynes, alcohols that we are familiar with already, carboxylic acids, esters, and a few others. All right. So starting with alkanes, alkanes actually belong to saturated hydrocarbons, which pretty much clears out the fact that alkanes are made up of single bonds only. So as you can see in the key definition, they are saturated hydrocarbons. The molecules will only consist of single bonds. There are only carbon and hydrogen present in the chain. And there is one more thing, general molecular formula. When it comes to that, we need to redefine all the types of formulae that we have previously discussed and what we are going to quote over here. So what I'm going to do is that I'm going to stop this sharing. I'm going to open up a Word file and we are going to discuss the different types of formulae. Now, these formulae are present on the internet as well, but I didn't find much of the help from the internet because the type of formulae that are given in our book is somewhat different than the collection. I don't mean they're not present on the internet, but they are scattered on different websites. So what I'm going to do is that I'm going to collect all the ones that are part of your book in a Word file. So let me stop the sharing over here. Just give me a moment. So I hope you can see the Word file. So what we are going to do is that we are going to simply discuss 5 different types of formulas, and how we're going to do that. Just give me a minute and I'll get started on that one as well. So what we are supposed to do over here is actually, let's do it like this. Quick setting. Okay, now it would be visible in a pretty good way. So let's go with type of formulae, and we're going to cover some of the old ones that you have previously studied in different chapters, specifically chapter number 3 and 4, when we were discussing bonding and chemical reactions and their types and how to quote them and how to discuss different formulae. So what we are going to do over here is that we're going to go with different types. As goes with the first type, is molecular
So
formula.
ये हमने लिखना है.
No, you don't. You will get the whole file. Why do you think I'm creating a file? If you're supposed to write it too, you'll get the file. Then you might want to copy it on your copies, or you want to keep the original soft form file. It's entirely up to you. So for now, let's just understand it. Okay. So why don't I start asking a couple of questions, because the first type, molecular formula, is something you are already familiar with. So starting with Rafe. Is Rafe here? If Rafe is here and he can hear me, then let's say, or if he has a problem with mic, let's move on to Wase.
Assalamualaikum sir. Assalamualaikum sir.
Walaikum assalam. Anji Rafe, how are you?
Fine sir.
So do you remember what molecular formula was?
Sir, I think that it shows the actual number of atoms of each element present in the compound or molecule.
Wonderful, wonderful. It shows actual number of atoms of all the elements in a compound. It's a very easy definition. So that's it is all. If someone doesn't understand what that is, let me know so I can revise it for you. All right. So moving on to the next one. Why don't we ask it from a girl? Zoha, are you here?
Yes, sir.
Auntie Zoha, can you define empirical formula for us? Let me remind that we studied back in 6th chapter. If you don't remember it, that's fine. You can simply
It
say it
shows
and
the
we can move
simplest
on.
ratio,
Simplest ratio of what? Very good.
atoms present.
Very good. Simplest ratio of all the atoms of all the atoms present in the compound, right? Very good. If someone doesn't understand this definition of empirical formula, let me know. So next one is dot and cross formula. Who is going to define that? Let's ask Zaim. Zaim, are you here?
Yes sir.
Yes. Do you remember the dot and cross formula from chapter number 3?
सर याद है लेकिन डेफिनेशन नहीं याद मुझे.
So let's define it in your own words. Use English or Urdu, I don't mind. खुद से define करने की कुछ थोड़ा सा बताने की कोशिश करें. Even if not the exact definition. Acha, I'm going to give you a hint, and that would make it easier for you to express yourself and tell us the definition. For a little revision, हमने dot and cross formula में electrons को represent किया था with dots and crosses. Does that ring a bell? one atom with dots and the other one with कुछ याद आया या हम आगे मूव ऑन करें?
यस सर।
सर याद है सर, वर्ड्स नहीं समझ आ रहे सर, किसने एक्सप्रेस करो?
हम किसी और से पूछ लें, if you don't mind.
ठीक है सर।
हाँ, let's not waste time. ठीक है, हम किसी और से पूछ लेते हैं। ये सभी किसने कहा है? Was it शाजेब और आयान? कौन यस कह रहा था अभी?
सर मैं था।
शाजेब, can you define it for us? याद है आपको?
नहीं।
अभी जो मैंने बताया उसी को रिपीट कर सकते हैं?
के एक को डॉट से रिप्रेजेंट करते, दूसरे को क्रॉसेस से।
और किस चीज को रिप्रेजेंट करते थे? इलेक्ट्रॉन्स को। एंड इफ यू रिमेंबर, और इलेक्ट्रॉन्स किस शेल के होते थे? outermost shell ke, valence shell ke. Right. Good. So that defines it all. So what do? We represent the electrons of valence shells of elements. Okay, elements nahi likhna chahiye. Of atoms with dots and crosses. ठीक है? And that represented the bonding. आपको याद होगा कि इसको हमने covalent bond को represent करने के लिए भी use किया था back in the bonding chapter, and we also used it to represent the ionic bonding. In the ionic bonding, it was a simple case of loss of electron and gain of electron, while in covalent bonding, it was a case of sharing, where the electrons of the outermost shell or the valence shell were shared with one another. Do you remember? इतने revision से याद आ जाता है सबको?
Yes.
Good. अब पूछते हैं question आयान से. So Ayan, can you guess what structural formula could be? Although we have studied that back in chapter number 3 as well. Structural formula क्या होगा?
So a formula which shows the arrangement of atoms in a molecule of a compound.
Very good. Arrangement of the atoms as well as what? There is one more thing.
Atoms and in the molecule of a compound.
Atoms and their bonds in a molecule of a compound. All right, that would be a much better explanation. Back in chapter number 3, you studied only atoms, but here in chapter number 10, when we come to organic chemistry, and we are specifically discussing a whole lot of covalent bonding, and with all its type, the single covalent bond is there, the doubles and the triple bonds are also going to be here in the few next portions of the chapter. So what we are supposed to say over here is that it represents the atoms as well as all the bonds in the specific compound. Okay? So in a compound for that definition, and in this case represents the atoms and the bonds in a compound. Okay? So general formula, what would that represent? Take a guess. Anyone? Okay, what does the word general in English means? That I hope anyone can define. उर्दू में बता दें अगर इंग्लिश में बताना मुश्किल हो रहा है, because general is such a typical word. Okay, if no one's going to take the initiative, let's, without wasting any time, explain that general means in order to generalize or genericize something. Okay? It means many things could be represented by one similar pattern or one similar behavior or one similar diagram or any representation that we can talk about. Okay? Here we're talking about formula, so it means the representation is going to be a formula. Now, can you imagine one formula representing a whole lot of sets or formulae in a series of compounds? It seems difficult. जब आप अपने पिछले पढ़े हुए कंपाउंड्स को सोचते हैं तो आप सोचते हैं कि वाटर का फॉर्मूला सॉल्ट के फॉर्मूला से और सॉल्ट का फॉर्मूला शुगर के फॉर्मूला से कितना डिफरेंट है. They are so different from one another, so they can never be genericized. They can never be a general formula which could represent salt and sugar and water at the same time. But in case of organic chemistry, the compounds are made up of only carbon and hydrogen, two elements only, and the same elements every time will be used to make them in different proportions. So yeah, general formula is a very good possibility to represent them. So represents, it actually represents the entire family of organic compounds by one specific formula. ठीक है, ये पूरी फैमिली ऑर्गेनिक कंपाउंड्स की एक स्पेसिफिक फॉर्मूला से बता देगा. So in order to understand this all, in order to get a better concept, it's good to either use diagrams or use examples. Diagrams can become a little bit messy and time taking over here. So what I'm going to do is that I'm going to consider examples. So let's consider examples over here. Okay. So coming to the point. Example, an example of molecular formula. For example, water is represented with
H2O.
H2O.
right. Water is represented with H2O. So let's talk about empirical formula. Water again here is represented by what?
H2O 2:1.
Not exactly, but H2O. Okay. Why? Because the simplest ratio is already present in molecular formula, and in the case if simplest ratio is the same, the molecular formula and the empirical formula are also same. Hence, in order to eliminate that problem, we are going to take a couple of more examples. So let's take the example of glucose over here.
CH2O.
No, let's go with the molecular formula first.
So
C6H12
H12O6.
O6, right, right.
O6.
ठीक है, अब ऐसा करते हैं कि आप इसे क्वेश्चनिंग फॉर्म में करते हैं. बॉयज ने बहुत सारे क्वेश्चंस के आंसर बता दिए. लेट्स मूव ऑन टू गर्ल्स. हम जोहा से एक क्वेश्चन पूछ चुके हुए हैं. लेट्स आस्क फ्रॉम अदर गर्ल्स. इज ज़ैनब प्रेजेंट ओवर हियर? ज़ैनब, are you here? Okay, what about Tanisha? Tanisha, is you here? Are you here? Yes. जी, Tanisha? I think she joined at the start of the meeting. Yeah, Tanisha's here. Tanisha, can you hear me, beta? I think she has a mic issue. Tanisha, as you have a mic issue, so let's talk in chat. Tanisha, what do you think the empirical formula of glucose would be? Only Tanisha is going to answer that question, so the rest of you, please stay quiet. Tanisha, why don't you write it in chat? You don't have superscripts or subscripts in chat, so keep it simple. And if you don't know, let's not waste time. Simply write, I don't know, and we can move on. I can ask someone else, whomever knows the formula of the empirical formula of glucose, actually. Tanisha, come on. You didn't need to write the formula, or you didn't. Okay. Tanisha says she doesn't know, or she can't remember. So who's going to tell us? Not Shazeb, not Ayan. I'm going to ask someone else. So let's take a look at the participants list. What about Kabir? I haven't asked a question from you so far. So Kabir, what do you think the empirical formula of glucose is? Kabir, you can also write in chat if your mic is not working. That's fine by me. And if you don't know, you can write the same thing in chat that you don't know. Very good, Kabir. Kabir says it's CH2O. Okay, Kabir, are you going to, okay, let's ask Zain. Zain, can you tell us the reason why the formula is CH2O for glucose in empirical, while the same thing was C6H12O6 when it came to molecular formula? Can you tell us the
So
reason?
in empirical formula, we have to find out the smallest ratio of the formula.
Very good, very good. So which number did you divide it with to get this smallest ratio?
Sir, 6.
Very good. That's good. So I think everyone can understand over here how the molecular and empirical formula are related. And with the correct answers that came from Zain, you should know how mathematics is related to all of this stuff. Okay. So moving on to dot and cross formula, take a look in the book. The formula of glucose is given in the book. We were just studying it. The formula of water is present on page number, actually I don't know the page number, it's present in chapter number 3 in the covalent bonding portion. The structural formula can also be taken for different components here. It's going to be a little difficult if I try to write the dot and cross formulas or structural formulas for that matter. Okay. However, if we talk about general formula, what I'm going to quote over here is what I'm going to do over here is that I'm going to quote a couple of examples more just to make sure that we also understand the general formula. Okay? So let's talk about a couple of more examples. So let's start with methane. Okay? Who's going to tell me the formula for methane? How about Rafi? Vasi, you are next.
CH4.
Huh. So Rafi, what would be the empirical formula?
Sir, CH4.
Right.
Because
And why
it
is that
is
so?
simplified already.
Already simplified. Good answer.
Sir, because it is already simplified.
Right, right. Perfect, perfect. So, do you remember the structure of CH4, Rafi? It was simply carbon in the center and all 4 hydrogen were surrounding the carbon. If you don't remember it, let's revise it like this. Okay? So,
page 69 there.
Page number 69. Thank you, Ian. Page number 69. So let's take another example. If someone remembers ethane. G.
Sir, C2H4.
No, it wasn't H4. It might not be present on page number 69, but I guess that is present on page number 70. Is it? Or is that
Yes,
ethene?
It is ethane.
C2H6.
C2H6. Very good, Shazid. So that is C2H6. In that case, we have C2H6, two carbon atoms and 3 hydrogen atoms. Oh, sorry, 6 hydrogen atoms. So is that correct for the empirical formula?
No, sir.
No, sir.
No.
No, sir.
So what would that be? Any girl, not a boy.
CH3.
CH3, very good. Who was that?
Soha.
Zoha. Good work, Zoha. Okay, so I can't draw the dot and cross formula or the structure formulas over here. You can take them from the internet. They're easily available on Google or Google Images, especially as we're talking about images over here. But let's talk about a general formula. A general formula cannot be based on an empirical formula as they are not the true formula. In all of these formulas, a formula that is known as true formula is the molecular formula. So what about general formula? Can you genericize the formulas of methane and ethane? Because definitely water and glucose are not made up of the same elements, only methane and ethane are. So they can only be the ones that can be generalized. So talking about for methane and ethane only. If you have the book and the page number we were at, the general formula was given at the very bottom in the key definition of alkanes. Why don't we ask Tanisha to look it up from the book and then tell us the general formula. It's actually the last word on the page we were just studying. Very last word, very last line. Key definition of alkanes. Yes, Tanisha. Just a second, let's see the chat. CnH2n plus 2. Very good. So, I actually wrote 2n plus 1 in the start. All right, Cn2n plus 2. Can you understand this general formula for the actual molecular formulas of ethane and methane? It's very simple. The N represents the value of carbon. And if you have a specific formula for, if you have a specific number of N, multiply it by 2 and then add 2 to it and you'll get the number of hydrogen. It's very simple. Take a look at this N. If this is N is 1 and we put 1 over here, the number of hydrogen would be 4 and that is the formula of methane. If the N is supposed to be 2, we multiply 2 by 2, that is 4, and add 2 to it, that is 6, which is the formula for ethane. So it can give us the formulas for the entire family of alkanes. So not only methane and ethane, let's cut the word methane and ethane. True for all alkanes. Now, this very much writes the truth. Do you understand how we are converting a general formula into molecular formula? If anybody doesn't understand, let me know. Because if you do understand, we're going to practice it by asking you different questions.
Sir, N क्या है?
N is the number of carbon atoms. It could be 1, it could be 2,
Sure.
it could be 3, it could be 100, it could be 1,000, it can be anything. However, in generic, on this planet, so far, the N we have found is up to 70 or 72. In the compounds that we have found so far. There are some exceptions to this rule, but so far, that is good enough for you. So it can be any whole number from 1 to 70. So any questions? Or should I start asking questions? Okay, let's ask questions from all the participants to make sure that you understand it one by one, starting with Zoha. Zoha, if the number of carbon atoms is 9, what would be the number of hydrogen atoms according to the general formula? Because if n is equal to 9, 2n plus 2 is equal to, that's very easy. Multiply the number by 2 and then add 2 to it, you'll get your answer.
20.
20, very good. Kabir, you're next. This time you have a compound in which we have 30 carbon atoms, 30 carbon atoms. So what would be the number of hydrogen atoms? Kabir, you may write your answer in chat. Moving on to Vase. Vase, the number of hydrogen atoms are 40. What would be the number of carbon atoms? Good work, Kabir. The number of hydrogen atoms would be 62. Vase, what about you? Number of hydrogen atoms are 40. So if we subtract 2 from 40 and then divide it by 2, you'll get your answer. And what is that?
So,
A little bit of mental maths, come on. So first of all, subtract 2 from 40, the answer would be? No, that's not right. Subtract 2 from 40 first, the answer is?
38.
And divide 38 by 2, the answer is?
So 19.
19. There you go. Now you're correct. Okay? No, Ayan, you're not going to help him. In fact, Ayan, let's take you next. So Ayan, if the number of hydrogen atoms are only 10, what would be the number of carbon atoms? Rafi, you're next. If the number of hydrogen atoms are 50, what would be the, if the number of carbon atoms are 50, sorry, carbon atoms are 53, what would be the number of hydrogen atoms? Ayan, you are going to say your answer first, then
So
Rafi.
4.
4, very good. Rafi, your turn.
Sir, 102.
1 or 2, very good. So it's a simple exercise to do that. Let's ask the rest of the people. Shazib, your turn. What would be the number of carbon atoms if the hydrogen atoms are 32? Tanisha, you're going to be next.
15.
Very good. Tanisha, you're next. And the number of hydrogen atoms were 200. What would be the number of carbon atoms? Now this goes beyond our limit, beyond what I've told you. So it's a little bit of mathematics. Let's come up with the answer, even if the compounds exist or not. We're not discussing that right now. Tanisha, number of hydrogen atoms are 100. Oh, sorry, 200. Zaim, I think you're the last one left. Zaim, your question is going to be the number of carbon atoms at 38. What would be the number of hydrogen atoms? Tanisha is writing her answer in the chat. 99, perfect answer. Good.
So 78.
78, good work, Sain. So I think that is very easy and it's a common practice in questions and there is not even a mark for that. IGCSE इसके ऊपर कोई marks भी नहीं देती है, इससे अगले question के part पर marks देती है, but so far इतना काम आपको खुद से करना होता है, ठीक है ना? कि आपको ये फाइंड आउट करना होता है कि कितने हाइड्रोजन एटम्स या कितनी इस तरह की चीजें होंगी या कार्बन होंगे अकॉर्डिंग टू द नंबर एंड फ्रॉम द जनरल फार्मूला यू आर गोइंग टू कम अप विद द फार्मूला ऑफ अ कंपाउंड. ठीक? So is that good enough of a practice for all of you to understand how we are going to relate the general formula with molecular formula and so on and so forth? Any questions? If you have a confusion, say so. If you don't have a confusion, let's be quiet. So I'll get for the whole of the class as an answer that you don't have any confusion. We can move forward. All right, good, good. In that case, that is so far what we needed to do in terms of formulae. In this case, structural formula is something that we need to still explain. Okay? In order to explain that, I'm going to stop this sharing for now, and I'm going to move on to the next pages of the book to take help from the book, as it needs a little bit of drawing, and drawing may take time. So what I'm going to do is that, let me just save this file. Let's save it on desktop, types of formulae, and move on to the sharing of the book. All right. So these were the types of formulae, and the formulae are covered in this pink portion. Okay, let me annotate that for you. In this pink portion, the empirical formula, the molecular formula, the structural formula, how the molecular formulas and empirical formulas are connected, how you're going to take examples. We are done with all of these examples. Okay, there is a little bit of other things about structure. We will study them a little later. Let's just move on to what I want to show you. Okay, formulas. Let's take a look at their structures and structural formulas. Starting with the very first member of alkenes, methane. It is completely made up of carbon and hydrogen, and as I was talking to Rafe, we usually draw it in such a way that the carbon is center and all four hydrogens are covering the four sides of the compound. I think that's pretty easy to understand, the structure of methane. However, when it comes to two carbon atoms, the structure of ethane, both carbon atoms are connected by a single covalent bond, like you could see in case of spotlight over here, and both carbon atoms are actually surrounded with 3 hydrogen atoms each. So the overall formula for ethane is C2H6. You can simply do that by counting the number of carbon atoms and counting the number of hydrogen atoms. and it can be a very easy activity. For example, Zoha, I would like you to go ahead and count the number of atoms for hydrogen and carbon atoms for pentane and tell us what the molecular formula should be. How many carbon atoms are in there and how many hydrogen atoms are in there?
C5H12.
C5H12. See, that's a really easy activity. As far as the other compounds are concerned, we are going to stop right here, and I'm going to pick from this diagram tomorrow, and we're going to exercise a little bit more so as to make you familiar with the diagrams, with the structures, with the working of organic chemistry. And this is what organic chemistry is about. We're going to discuss with the help of their diagrams and how did it look, how do we write their formulas, how do we genericize it. Okay, if you have any questions, we're going to handle them tomorrow. Time's up. So take care, class. Allah Hafiz.
Good afternoon.